Hello everyone and welcome to a new episode of the Inference Podcast. I'm your host Michele and today I'm incredibly happy to have here with me Luciano Mammino from Ireland, if I'm not wrong. How are you, Luciano?
Hello, Michele. Thank you very much for having me. I'm really happy to be here. I'm actually really excited. Yeah, I'm good today.
Yeah, I'm excited too. I would like you to present yourself, what are you currently doing, and I don't know, something that you'd like to talk about for starting the conversation.
Yeah, sure. So, yeah, my name is Luciano, as you said, and I'm working in Ireland, in Dublin, for a company called Four Theorem. And I'm working there as a senior architect. And as a company, we are a service company that it's mostly specialized on AWS and cloud. Like most of our customers, we are helping them to either migrate to AWS or if they are already on AWS, maybe revisit their architecture and make sure that they use AWS in the best possible way for their business. So it's interesting because I'm working there now as a cloud architect, even though for most of my career I've been a full stack web developer. And only in the last, I guess, 4 to 5 years, I've been doing more and more AWS and infrastructure. So I'm realizing I'm kind of transitioning from that full stack background to a more cloud architect background, even though I still spend most of my time working on the web and writing software. So I have still a pretty much hands-on role, not just designing architecture, but also implementing stuff.
Okay, that's amazing. And before we get into talking about cloud architecture, because I promise we will be there in just a second, I also know that we are kind of colleagues because you've published a book for Packet Publishing, which is the publishing company that is gonna publish my own book. So we are kind of colleague in a certain way, and I'd like you to present your book maybe because I've read it and I'm half of the book, to be honest. I haven't completed it yet, but I'm really enjoying it. So if you want to present the book and what is it talking about?
Yeah, I'm not gonna miss out on this opportunity, and thank you for giving it to me. So this is the book. I'm gonna show it.
Yeah.
So the book is called Node.js Design Patterns, as you can see, and I co-authored that with Mario Casciaro, that you can also see there in the picture. And maybe I'll tell a little bit of the story, but let me introduce the book first. So the idea of this book is basically I suppose that the target audience is that web developer that is knowing, I guess, enough JavaScript to understand how JavaScript works, but maybe starting to look for their first professional job and they want to get a better understanding of the JavaScript ecosystem with a major focus on the Node.js backend side, even though there are some chapters that are more about the front end. And the idea is that JavaScript is one of those languages that are very powerful and they kind of look easy on the surface, but then there are a lot of pitfalls and things that the mental model behind them, it's not as simple as it looks. Like it's very easy to just copy paste something from Stack Overflow and change a few things and everything works. But then when in real life, when you have to build something from scratch, you really need to understand how the code is being executed, how the asynchronous models work, and all these patterns that will help you to actually structure everything in a good way. So this is kind of the goal of the book, and I think it's trying to condense several years of shared experience between myself and Mario and all the pitfalls and mistakes that we found throughout our career, and we are trying to kind of show them in a way that should be a little bit more approachable and more organic, so you don't have to bump into the same mistakes to learn those concepts. But in theory, by reading the book, you should be able to feel a lot more comfortable that your code can go to production without any major incident. So this is, maybe I'm making it a little bit too long, but this is where the idea of the book is coming from.
Yeah, I gotta say, I work on Node.js on daily basis, so I would say I'm a kind of professional Node.js developer, and I found your book really instructive and makes me feel more productive when I work on Node.js after looking at certain design patterns that I wasn't considering because, JavaScript is such a language that, just as you said, it's really powerful, but shares some concepts that are not common to every single language out there. So if you're coming, let's say, from Java, PHP, there are certain differences that makes the whole developer experience really different. And that book specifically is helping me a lot understanding some things that I don't even think about when I'm writing JavaScript, because I am already in the mood of writing JavaScript, of course, but the inside, the performance analysis and enhancements and concurrency models, those things are really, really interesting and really well written inside the book. So I want to thank you personally for the book. And yeah, so I'll leave the link for buying the book if anyone is interested in the description field for the YouTube video. So yeah, I really hope you all find this useful too. Okay.
Thank you very much. I'm really glad that you played that you are enjoying the book.
So moving on, you said that you started your career as a full stack software developer on the web development domain, and now you're slowly transitioning into the cloud architect role. I'd like to ask you, what are the main differences that you've seen in your daily job when, talking about the differences between being a full stack developer to a cloud engineer? Because I've seen many people wondering on Quora or Stack Overflow, which is the difference between an engineer and an architect. And I want you to answer that question, but also talking about cloud architecture, which is way different, when compared to standard architect role or legacy architect roles.
Yeah, that's a very tough question. I'll try to give you, I guess, a view into this question, but definitely it's going to be a personal one. Like, I'm not going to claim I have the answer. I suppose what I've seen, or at least how I would like to define the role for, at least for myself, maybe it doesn't apply to every other cloud architect, is that I think on one side it's very important that for me I have that development background, because at the end of the day you are building something that is made by different parts, and I think the software part is as important as the cloud architecture part. So for me, coming from that background, it's very useful because I think I have a good wide spectrum in front of me, and I can try to understand how different parts fit together. So I suppose my transition has been happening quite organically, and it's not something I was really planning to do. I guess it's just luck. I was in the right projects at the right time, and I was able to take a little bit of that responsibility of not just building the software part, but also work with other people and put that software into production. And I think progressively I found myself taking more and more that responsibility, to the point that I think now I understand enough to be able to design and release cloud architectures where I'm kind of taking a little bit more of that ownership. Like, I'm not just doing the software part, but I'm also doing the design of the cloud architecture, and then making sure that everything is put to production and it works as expected. So I don't know if I'm answering the question, because I'm not really giving you like a plan on how do you get there and what are the differences. Because to me, I didn't see too many differences, because I think I'm still doing, to some extent, both roles. So it's kind of hard to say in isolation, this is what you will do in one role and this is what you will do in the other role. I think it's just an extension of my original role, if you want to see it that way. And maybe what I can tell you is like, what are the new bits and pieces that I'm seeing that makes me think that now I am a cloud architect and not just a software engineer anymore. I think that the main difference is that when you work as a web developer, generally you have like a language of choice, let's say Node.js, you have a framework of choice, just to mention one, let's say Express, but can be anything, can be Fastify, whatever. But essentially your role starts where you get a set of requirements and you have to build a platform, you have to build something, let's say an e-commerce, you start to build it, it works on your machine, you have tests, you have everything, you are happy, and that's where your role finishes generally, right? You, as an engineer, you have to build something that works in your machine, you write the tests, you push it to GitHub, and then in most of the cases, most of the companies I've seen, you basically your job is done, somebody else will figure out how to put that into production. Maybe there are some let's say shared conventions just for lack of better words, where the code is structured in a certain way. I don't know, in some cases, maybe you have Docker containers, so you need to make sure that that Docker container is built and it works, but then you are not really in charge of shipping that Docker container to production. Maybe in some other cases you use things like Heroku, so it's even more lightweight on the developer. Like, yeah, there are some standards, but the developer doesn't even know how the code is running in production. So I think the difference starts there. Like when you start to worry a little bit more on, is this thing really going to production, and how, and what happens when is it in production? Is it really running in a way that is performant enough? Is it cost effective? Can we roll back if we need to? Are we seeing any, I don't know, indication that maybe there is an incident going on and we need to intervene? I think when you start to put all these questions on the table, then naturally you are starting to shift your attention a little bit more on all the aspects of, yeah, the software exists, how are we actually running this in production? So I think that that's maybe the link there. When you start to explore that path, I think that can be the right trajectory to, I'm going to say, expand your role, because again, I'm not seeing my role as totally disjointed from the software engineering role. I'm just seeing it more as an extension.
Okay. And at this point, I don't want maybe newcomers to the software engineering and architecture world to have like a little confusion about software architect role, because I feel like we hit certain points that in many companies are actually handled by DevOps engineers. So my question is, where does the software architect role starts and where does the DevOps engineer role starts? Because for certain companies, probably, but please tell me if I'm wrong, I feel like smaller companies don't really have a DevOps engineer dedicated to deployments and setting up the cloud architecture. Maybe this is something that a software architect can do, because software architects typically could have the capabilities for doing that in a company. So in medium or bigger companies, there might be the DevOps engineer working on something else. So I'd like you maybe to answer this question. Where do you think that architects and DevOps can cooperate, and where one can take the ownership on a certain part of the pipeline to production, and where the other one takes another part of ownership?
Yeah, absolutely. That's a very good question. And again, I'm not going to try to dodge the question and give you like a vague answer, but it really depends on the type of company that you have. Maybe I've been lucky enough to work in, I guess, small team with a lot of potential. So working on big projects, but then the core team is still fairly small, that you can see all the different bits and pieces and have a little bit of ownership in different parts of the whole project. So it's kind of weird to draw like a clear boundary in those cases, because you get to do a little bit of everything, because you don't have all the people in the room that they can take like individual responsibility. Like you have few people, fewer than you need, so everyone needs to do a little bit more than usual. But one thing that I think it's worth mentioning is that DevOps as a terminology is always a little bit confusing.
Yeah.
Like I think in the industry today, it's, especially if you talk with recruiters or hiring managers, the idea of DevOps is somebody that takes care of the infrastructure. But then if you read all the canonical books about DevOps, it's more, DevOps is not a role. DevOps is a philosophy. It's when in the company, everyone is responsible for shipping things to production, and there are certain best practices you follow. And it's like, there is no more manual steps, basically. It's like you try to apply the technologies and the practices that in software have existed for a while. Like, I don't know, we have automated tests and things like that, but you start to apply them also to shipping software to production and try to do that as often as possible during the day. So yeah, it's always tricky to say what is the difference between the DevOps role and something else, because even the DevOps role is not well defined, in my opinion, and maybe shouldn't even exist as a role.
Okay, yeah,
So
I get it.
if you ask me. But again, let's leave that aside for a second. So I suppose the question is, if you have somebody responsible for the infrastructure and somebody like in terms of shipping things to the infrastructure, and somebody that should be more of a, let's say, a designer of that infrastructure, somebody that thinks more how everything fits together. I think if you have a big company, maybe with established products and maybe a number of different products that needs to kind of fit well together, probably makes sense to have one person dedicated, or maybe a group of people dedicated to just seeing, okay, given the architecture and given our vision, let's make sure that the architecture is up to the standards that we need to be to, I don't know, build more feature or scale more or whatever is the vision for the next 5 years. In reality, at least in the cases that I have been where you have few people, maybe the projects, yes, they are ambitious, but they are still kind of more early stage. I think in reality, you need to have everyone in the room. Of course, you're going to have more senior people and less senior people. Different people will have different responsibilities. But I think you need to have that global view where everyone understands this is our mission, this is our critical points for succeeding or failing. How can we build something that, yes, then we can ship and is going to match our expectations? So again, maybe it's just me. I've been lucky enough to be in these environments where you get to have this conversation. You are not just executing on somebody else's design, but you are actually involved on saying, I don't think this is the right way. Let's consider this other way, rather than just say, okay, I'm going to do whatever you think is correct. So if I were to build my own company, I think I would prefer to have that kind of environment where, of course, if you are more senior and you have more experience in terms of cloud architecture, you are probably going to have more importance in that conversation. But other people that will write maybe the software, just to keep the example of the software engineer, they will have another perspective that you need to consider. So it's good to have that conversation. Again, I feel like I'm dodging the question, but I think that that boundary is not so strong as you will probably see in more traditional companies where you have the software architect that just draws boxes in the whiteboard and then somebody else is executing it. And then there is a huge disconnect, in my opinion, between what's happening in reality and what's the architect is thinking that it's the real architecture.
Yeah, no, I get your point, and I feel like this is a conversation that needed to be done at a certain point to define, as you said, the boundaries, because even though we didn't define any, that makes clear what is the role for a software architect instead of a company, and that's really important, because if you look at the questions that maybe new developers ask on the internet, you would see that it's not really clear what a software architect does. And there are certain intersections between the role of an architect, the role of a DevOps engineer, the role of an engineer itself. So it's not really easy for, again, newbies. Let's go in this way. We all be newbies. And I bet every single one of us, me included, have asked that question. So where do you draw the line? And as if so, there's no real way for drawing a line in that case. And that's actually an answer. And so thank you for your answer.
No, I think it really depends on the structure of the company. Like there could be companies where there is a very strong line. Like again, maybe there could be one person in charge of designing the architecture. It's delivered to the engineering team, and then the engineering team executes that design. But for instance, the architect maybe doesn't write a line of code to make that design happen. Yeah. In other companies, could be a lot more collaborative, and maybe the role blends between designing that architecture and actually implementing it, which honestly is what I prefer. But again, this is very personal, and this has been mostly influenced by my experience. Maybe if I was working in different type of companies, I would have a different expectation for what an architect should do.
Okay, I got it. I'd like to go a bit deeper into the software architecture, the cloud architecture stuff, because before we hit the record button for this episode, we were already making an episode talking about cloud architecture, and we were talking specifically about microservices, which, of course, this is like an holy grail of many companies and developers and architects, because it's cool, it's new, it's something that really makes our life easier in many circumstances. But at a certain point, you may ask yourself, is it worth it? So I would like to discuss with you the microservices seen from the cloud architecture perspective. So one pros and one cons, in your opinion. Let's start from there.
Right. Okay. One pro of microservices would be that I think I'm going to phrase it this way, that basically the main pro of microservices, in my opinion, is that you can organize your team in a more structured way, and your team can have ownership on parts of the application. So it's easier to do progress, because different teams can own either different applications or different parts of the application. They can operate most of the time without having conflicts with other teams. They can operate independently from other teams. So in my opinion, you should start to consider microservices when you see that it becomes hard for teams to work together and make change on the code base. That would be the main pro. If I have to give you a con, instead would be that, of course, that switch of model generates also a lot more complexity. And one of the main complexity I'm seeing is observability, because you have been working with something monolithic, then you go in one place and you find all the information there. And when you have microservices, or even worse, when you're doing serverless, and we can talk about that, everything becomes a murder mystery. I'm stealing this phrase. I saw somebody tweeting that a few days ago. But the point is that every time you need to find what's going on, you shouldn't look only one place. You need to put a lot of information together and try to make sense of it. So, of course, if you don't have tools, if you didn't put too much thought into structuring the data, it can get very, very complicated to the point that you don't really know what's going on.
Okay. Before we get into observability, once again, you hit a nice point, in my opinion, which is you talked about a pro of microservices that is not related in any way to performances, cost effectiveness, and the speed of development. I mean, you talked about the organization of teams working on the product, which is strange to me. I mean, I get your point, but that wouldn't be my first thought when I think about microservices. When I think about microservices personally, for the way I started doing this job, is okay. Microservices are good because you have more performances in many cases. You can scale better for many reasons, but eventually you told me something. You haven't denied this, but you hit another point, which is developer productivity, basically. So I'd like to go a bit into performances and scalability and cost effectiveness, which is something that I feel like is not really considered when we think about serverless programming or microservices, because we feel like, okay, let's talk about AWS Lambda, just for example. It's really cheap, right? But eventually, when you start to think about, I have to deliver billions of lambdas per day, is it really worth it? So, how do you feel about not the pricing model, but the fact that sometimes it is worth it to have a worse developer experience for, cost effectiveness, which is not something that we aim to as developers, but it's something that we should consider when, building a startup, building an MVP or a POC or whatever.
Yeah, no, that's a very good question. I can probably refer to a project that I've been involved with, where it was a project that we built in like 6 months, and it was already in the market making millions. So for me, it was one of the most successful endeavors I did in my career. But it was interesting in terms of actually this conversation, because we built almost everything serverless by default, because the rationale there was, we know this thing is going to have a lot of volume. Like, it was mostly a data pipeline indexing terabytes of data.
Okay.
And we had already multiple customers in the pipeline, but we didn't know how much every customer would push in terms of data, and how many more customers would we get in over like the next few months. So we just said, okay, let's build this with serverless because we are sure it's going to scale. And that's also not entirely true, because even if it's serverless, you still need to be there and tweak a number of things that are not obvious. Like serverless is not magic, it's not going to do everything for you. Like you still need to be there, understand what's going on, and tweak things.
Yeah,
And
absolutely.
they will break for sure. Like it's not an holy grail. It gives you more power, it gives you more flexibility, but you need to really understand the model. What was interesting was that after 1.5 years, that project got a lot more stable. Even our pipeline of customers wasn't growing as fast as the first few months. And at that point, we realized, okay, now we can exactly predict how much infrastructure we need to allocate for every customer. We even understand what are the metrics that a customer has and how they influence like the shape of the deployment. Keep in mind that this was not a multi-tenant solution, was like single tenant solution that we were deploying and replicating for every single customer, and it was sized accordingly to the need of the customer. But basically at that point we understood the business so well that we could say, okay, this customer with this volume of data, we can just allocate 4 EC2 instances. They're going to be running all the time because we get a constant stream of data. We are going to save a lot of money, which is counterintuitive because with Lambda you think it's always cheaper.
Exactly.
The reality is it is cheaper when you have very spiky traffic. And in reality, if you have very constant traffic, it doesn't get very spiky, and you get traffic constantly. Like it's not just in few hours during the day, but you constantly get that amount of volume. Then it gets cheaper to run your own EC2 instances if you provision them, if you size them accordingly to the need. So that was kind of an interesting realization I didn't consider before. And over time, we transitioned to that architecture because, of course, it was making the business more money to do that. And it wasn't really affecting, I guess, the developer experience, because at that point, we put thought into, okay, how do we keep ourselves capable of shipping changes in a way that we don't want to lose that ability of being fast at delivering. So we figure out all sorts of different ways that were good for us so that we can keep doing tests and packaging and release things fast enough.
Okay, that's really interesting, and as you said, counterintuitive. Because myself, at the first time, entering the serverless spectrum, I was like, wow, that's amazing. It's really cheap, it's fast, it's scalable. But eventually, I found out the hard way that it's not like it seems at first. So it really depends on the product, of course, as always. And okay, I want to go back to observability because you hit another point. So we may have a product which is really spiky, so we have we don't have a constant traffic. We may have certain periods of the day where we have a lot of traffic and other moments where we have nothing, basically. So talking about observability, do you have any suggestion for observe how the serverless environment is behaving under a high load of traffic?
Yeah, that's a very good question. And again, it's tricky because it really depends on how you build the product, even how you structure your lambdas, because even there we could probably talk for hours on all sorts of different approaches. I've seen from you put an entire Django into one lambda to every single endpoint, even every single method of an endpoint is a different lambda. So I think that's kind of the spectrum. You can go very, very granular, or you can consider a Lambda almost like a container and it runs an entire application to some extent. So I suppose in general, and also depends what kind of Lambdas are you running. Is it like responding to web events, like HTTP type of traffic, or is Lambda for, I don't know, processing data? So maybe you just drop something in a bucket, it will be fetched by Lambda and it will be processed. Or maybe it's even on a schedule, like cron jobs executing things over time. Or you could even have a more event-driven architecture, maybe using Event Bridge or something like Kinesis, where other parts of your application are dispatching messages, and then these lambdas will eventually trigger and do something. So I guess that's the first thing you'll need to understand. Like, what is the model there? Is it like synchronous? Is it asynchronous? What kind of events are involved, and what are the patterns? Then in general, you have the problem of correlating execution paths, because when you start to have this distributed system, it's most of the time you will have different parts of the architecture trying to respond to a specific, let's call it event, just to keep it generic. Could be a request, but let's call it event. An example could be it's an HTTP API, the Lambda will receive the call, but before the Lambda is invoked, it will go through API gateway. So you have a first entry point, then you have the Lambda. Maybe that Lambda needs to go, I don't know, to DynamoDB, call another API. Maybe that other API is implemented with another Lambda because it's another internal API. So I think the first thing you should do is understand that, and then try to figure out how can we trace the entire execution. And this is mostly because if you want to see why a specific event went wrong, you probably need to go back and see exactly, okay, in this path, what happened? Was it going through all the different steps? Did it break in any particular step? If it did break, what was the exception? Was this exception forwarded back, and what was the reaction in the point where essentially it couldn't progress anymore because somewhere else there was an exception? So I suppose tracing in these cases becomes very, very important to at least to deal with that use case where there is an error and you need to see what happened, why that error was generated. Then observability, of course, is much more than that, because you also have more high-level observability, which is probably actually the more canonical definition, where you should be able to tell if the system is working as expected by just looking at, I don't know, the average of requests. Are they going fast enough? Or is there a elevated error rate? Like, you don't think about one specific error, but you think more in terms of error rate. So yeah, observability can also be very, very granular, but can also be more high level. So you could have a range of tools to deal with the different levels of granularity.
Okay, so I'd like to go a bit off the path about talking about software architectures and cloud architecture. I'd like to go a bit on the programming language side because, as you may know, the Inference podcast is mainly meant for talking about programming languages. But eventually, I found out that software architectures, cloud architecture, it's something that it's really interesting. So that's why I've invited you, because I know you're really good at this. But I want to take a step back and talk a bit about programming languages. I'd like to ask you, before we go into the next topic, which is the Rust programming language, so that everyone knows that we will be going there, I'd like to talk to you about a hybrid between Node.js and Rust, which is Deno. So Deno, of course, for those who don't know, it's an alternative runtime for JavaScript and TypeScript, which is entirely written in Rust, basically. The bindings to the V8 engine are written in Rust. So I'd like to know your ideas on the Deno thing and the advantages and disadvantages that you see when compared to Node.js, if there are any, of course.
Yeah, I'm gonna put a little caveat there that I haven't kept myself up to date with the latest and greatest in Deno, and I know that they are investing a lot. They even built a company around it, so maybe my view is slightly obsolete. Let's put the caveat there. So I have a little bit of mixed feelings around Deno, because on one side I like that it's kind of an innovation, like they are bringing forward things that if they try to do them in Node.js, probably it would have been more complicated, because of course Node.js is a much more stable and structured project, and it's harder to innovate when you are at that scale that a lot of companies, a lot of people are relying on that product. You cannot do dramatic changes so quickly. You need to kind of get traction slowly and integrate things like bit by bit by following a more I don't know, gradual process. Instead, Deno was like, we don't care, we are starting a new thing, we can try all the different shiny ideas that we have been pondering with for a while. So it's kind of interesting to see that, because I think also as a response to that, the Node.js group started to consider a lot of ideas that maybe were going a little bit slower before. For instance, again, I don't know if this is really real history, this is just me inferring, but I've seen that after Deno there was a bigger push, for instance, for ECMAScript modules being adopted in Node.js. Again, maybe this is just coincidence, but I had a feeling that because in Deno that was being communicated as a major difference, that Node.js felt that they needed to kind of ramp up quicker and finish that delivery faster, because there was a little bit of competition there. So in a way that's also good to have that competition for Node.js. I am also a little bit disappointed because I see the whole Deno thing potentially as I don't want to say waste, because there are benefits for sure, but it feels like two conflicting forces that could work together, and maybe Node.js could be even better. Instead, they're kind of diverging and going into two different paths. So it might create more fragmentation as well. So that's my main concern and my grudge, I guess, against Deno. And also the other thing is that they are not, and again, this might be a little bit obsolete, but they are not compatible as runtimes. So if you write something that you want to be available for both Deno and Node.js, it might not be that easy or that obvious to create that package that works for both.
Yeah, indeed. So sorry, go ahead. Sorry.
No, that's why I'm concerned about fragmentation of the ecosystem, because then now JavaScript developers, they have to choose. Do I support Deno? Do I support Node? Do I support both? And if I support both, it's extra work for the maintainer.
Yeah, also this is a good point, because I found myself many times wondering, okay, I want to try Deno because there are certain things that for sure are killer features, such as out-of-the-box support for TypeScript, or security rules that are built in Deno, like access to the network, access to the file system. You have to explicitly allow that kind of permissions, or just the fetch polyfill, which is like, it's something I'd love to see on Node.js, but I also understand why they are not going to give that support anytime soon, because I read a thread. I don't want to tell what I read, because 100% I would be repeating wrong stuff, but there's a good conversation about that on the Node.js thread on GitHub. And there are also the fact that basically a Deno application is self-contained, so you have like a distribution package, and you take it, you ship it. It's really, really good. But at a certain point, I know that I cannot use, let's say, Express.js or Koa or Fastify. I cannot use the IO Redis for connecting to Redis. I have to use the Deno Redis package. And that becomes a bit frustrating, because you're used to certain libraries, to certain patterns. And as you said, it feels like a waste, because they could have, unite and enhance a product. But on the other hand, I see that competition, which is absolutely insane, because I also see that many announcements have been made on the Node.js side, because after Deno came out with such a potential. And of course, competition is always good on that hand. And also, going into talking about Rust, I feel like writing Rust add-ons to the Node.js platform. I think you can do that with Neon, if I'm not wrong. It's much harder than doing that for Deno. So Rust add-ons for Deno are way easier to integrate, which is something that definitely can beat Node.js. I never pronounced this in my whole life, so I hope I pronounced this correctly. But it's a mess. I really fear, I'm scared when I have to work with Node.js, and also I know that the creator of Node.js itself is scared of working with that because he told that during a talk. So I feel like I'm not the only one. And okay, so that apart, let me go back to Rust programming. How do you see the connection between Node.js and Rust? I mean, they are two different beasts, but at a certain point it might be handy to cooperate with such different languages. Do you feel like there is a connection between those two? JavaScript developers could benefit in some way by learning Rust, or the other way around?
Yeah, that's an interesting question, the way you phrase it. I'm gonna caveat that I am learning Rust not because I have, let's say, a business need or I saw like a direct value with what I do every day. It was more curiosity. It was more, yeah, this language is getting a lot of traction. Lots of people are talking about it. Let me see like why the big hype. And also I have to be honest, like I never really used a lot lower level programming languages like C, C++. Yes, I use them at the university. I use them while studying, but not really professionally. That's what I'm trying to say. So I was also curious to try to use a little bit more seriously one of those programming languages now that I have more experience and see like how does it feel. So I guess my view might be biased in that way, that for me right now it's just an experiment. I haven't really used it that much in production, so take it with a pinch of salt. Yeah, I think in general there might be good value in learning a different paradigm. This is something I actually encourage to do to everyone. Like even people coming from C++, I would encourage them to try JavaScript or Python just to see like the difference. I'm sure that they can learn one trick or two that they can bring back to C++. So in general, I am always advocating for trying different types of mindsets and tools, like even just from functional programming to object-oriented programming to mixed style of programming, because I think the more you learn, the more flexible you can be, the more easily you can understand different things. So that's for sure an encouragement to try Rust, especially if it pushes you outside your comfort zone. Other than that, I think there might be some interesting use cases that could come out from the combining Rust and JavaScript or Node.js. And I think, for instance, WebAssembly, there could be an interesting bridge. One example I've seen, even though, again, I didn't really spend too much time looking at the code, so I only have a high-level understanding, is one of the new HTTP libraries for Node.js that is called Undici. That is,
Yep.
I think, initially Matteo Collina created, and now it's more of a Node.js foundation type of project where multiple people are contributing.
Yeah, I've seen it hosted by the Node.js Foundation on GitHub. So I think it's going that way.
If I understood correctly, and again, take me with a pinch of salt because I didn't spend too much time digging in the code, but basically there is a core library that is written. It's for sure compiled in WebAssembly. I think it's coming from Rust. But the idea is that the slowest part, which is parsing all the HTTP protocol, that part can be done with something like Rust. Then you have a WebAssembly module, and then basically you have all the nice interface in Node.js, but all the hardcore part can be done this way. And this is not really a new pattern because I've seen this stuff also in PHP. Like there were entire frameworks where all the core logic and heavy stuff was done in a way that was compiled into C extensions. Yeah. And then basically you have a nice interface in your scripting language so that you can be very performant. So basically this is kind of the culmination of the two paradigms. Like when you do low level stuff, of course there is more burden on the developer, making sure that everything is done properly, but then you get a lot of performance. On the other end, when you do more scripting or high level languages, it's way easier for the developer, but generally you don't get as good performances. So I think combining the two things, you might find some nice trade-offs there where you can have still a very good performance, but also very good developer experience and being able to iterate very fast.
Okay, yeah, that's good. And I feel like it's the first time since like 50 years, probably, that C and C++ are going to be replaced in certain ways. let me explain. I mean, if we think of languages such as or runtimes such as Node.js, you have an interface to C++ APIs via Node.jyp, or if you think of Erlang or Elixir, you have nifs, so you can call C code. In Haskell, you have the foreign interface for calling C functions. The same applies to Golang and OCaml and many other, of course, Python, PHP, Ruby, many other programming languages. And that is the first time ever that I see another language coming into place and being the elephant in the room, saying, okay, I am the alternative to C and C++. And this is Rust, and this is why I'd like to learn more about Rust, because it's clear that something is happening and it's like replacing a half of a century old technology, which is still amazing. I have no doubts that it's still modern in certain ways. It's still very competitive. But Rust, on the other hand, it's incredible the way that it's proposing itself as an alternative. So that's why I personally feel like everyone should at least be aware of what Rust is, what are its capabilities. And that's really interesting, actually. I'd like to ask you at this point, which is the greatest difficulty that you found when switching from PHP or Node.js to Rust?
Yeah, that's a good question. I suppose I want to say first that I have a theory on why Rust is getting a lot of traction, and maybe that also answers a little bit the question, which is basically, I think that at this point in history, maybe if you go back like 10 years, when Rust maybe was just in the mind of the first developers that start to work on it, but it wasn't really anything that you could really use. I think at that point we had kind of a divide in the industry where either you are a system engineer, where you are doing, I don't know, C, C++, or compile languages more for infrastructure than for application directly. So you're kind of creating the environments where applications are going to run, but you're not creating the application themselves. And that's an entire world that I think has been a little bit more traditional. It didn't really evolve a hell of a lot like, for instance, the web did. Like with the web, there was a huge evolution, both in terms of technology, but also businesses that needed to kind of iterate fast and enable developers to ship things very, very fast. So I think we had this kind of divide where on one side, everything was still more traditional and things needed to be really, really solid and work really well and very performant, because that's like the basis where everything else is built on top. But on the other end, you need things that are really, really fast in terms of development and shipping. You don't really care that much about performance. So I think also developers, they kind of started to pick camps. Like either you are a system engineer or you are a web engineer, and you care about totally different values. Like the two worlds are totally disjoint, and often like there are jokes between the two groups. Like we are real engineer, but you don't build anything that is actually making money. Like there are these kind of jokes between them. And I think Rust is kind of interesting because it's positioning itself in the middle, and I think it's trying to bridge the gap between the two camps. And the reason why is because on one side is a system level language. So it's kind of very low level. You can build operative systems, or you can even build, I don't know, firmwares for boards, right? So you can go as low level as you want. On the other end, you can also go as high level as you want, because the language is built in such a way that you can easily build web framework and nice abstractions and be very productive with it. But I think the killer feature is that Rust tries to educate the developer to appreciate the difficulties that you have when you do low-level stuff. And this is something that it was interesting to me to explore, because, for instance, I never used C or C++ for any serious project. I think if I would try to, I don't know, write a video game or an operative system or whatever, even a stupid kernel for a simple motherboard or something like that, I will probably do all sorts of memory errors. Okay. And the interesting thing is that if you do it in Rust, chances are that 99% of these errors the compiler is going to catch and is going to tell you exactly what are you doing wrong. So if you do it in C or C++, it's going to take you 20 years before you realize all your mistakes and you become really at least confident that your code is going to do what it's supposed to do without crashing randomly. With Rust, is more, it's compiling, it's running, cool. Most likely this thing is going to work forever, like it's not going to crash randomly. So I think that's the killer feature that Rust figured out. And this is bringing the two camps together, because at that point, even engineers that come from higher level languages, they can start to appreciate all these memory concerns that generally they don't have to worry about. But at the same time, they are learning in a way that is guided. They are not just left alone to bump into issues until they can figure it out, which I think is what created the divide in the first place. Because if you start to go down that path, then it takes you years out of your career to learn all these things, where you are not really building products anymore, but you are building more foundational type of software. So that's the interesting thing to me in terms of Rust. And I found myself that I didn't even know, for instance, at the beginning, what is the difference between heap and stack? Yes, I did study that at the university, but then it was something I didn't really have to worry about anymore. And Rust kind of guides you into learning that again in a way that it makes sense. Like you understand when you use it, when you don't, and if you do a mistake, it's going to be obvious.
Okay, so you're telling that Rust can be a kind of programming languages that teach you how computer works. Would you say that, or is something, not really correct?
I don't know if it's 100% correct, but I think for sure coming from a higher level programming languages like I don't know, Python or JavaScript, you get to understand a lot more what's going on in the machine. And again, you understand it because as soon as you do something that will be wrong in C or C++, but you don't know until it's crashing, there the compiler is telling you exactly, sorry, you did this thing is not going to work, I'm not going to allow you to do that. By the way, go here and read why. Okay. And then you have kind of pointers in understanding what's going on. It could be a little bit frustrating at the beginning because even things that are very easy in higher level programming languages like JavaScript or Python sometimes become a little bit hard in Rust. But I think they will be even harder in C or C++. It's just that I personally didn't have the experience, so that kind of pushes me to understand more and explore more. And it's good that you have this kind of guided approach.
Okay, but coming back to my original question, so the biggest difficulty you had was indeed working low level, so memory management, that kind of stuff. And I feel like this is probably what scares me most, I gotta be honest. It's not the syntax, it's not the, the borrowing thing that I've tried a little bit of Rust and I was like, okay, what's going on here? This is really strange. I get why I should go into Rust, I gotta be honest. But yeah, writing low-level code for someone like me and eventually you that started by working on higher-level programming languages, working low-level sometimes can be scary, but it's comforting to me to hear someone who is taking this path and it's telling such beautiful things about a programming language that it's becoming disruptive in the industry. So I would personally recommend myself and other people who are listening, of course, to take a look at Rust. And maybe they won't like it, but I personally believe it is worth our time. So thank you for sharing your thoughts.
I'm going to add just one more thing, just to kind of close that point. One thing that I'm realizing by doing a little bit of Rust, and again, I'm doing it only for fun, small side project, nothing production ready. But just because the language, being lower level language, puts so much care for how things actually are structured in memory, even now when I write JavaScript or Python, I start to think, oh, am I copying data here or am I referencing data? Does it make sense to do this or that? Because I'm going to double the memory rather than just referencing memory that already exists. And all this stuff has always been abstracted to me by JavaScript or Python. even though it's there, and maybe even in JavaScript or Python, you have ways to avoid unnecessary copy, and you can use references if you want to. But because everything is garbage collected, you don't really, until you are using so much memory that things start to explode, you don't really have a problem. You generally don't even ask yourself this question. So I think doing a little bit of Rust is also good because it's going to make you think a little bit more on what you are doing, even with higher level programming languages.
Yeah, absolutely. Okay, so going into the conclusion for this episode, because it feels impossible, but we spent almost 1 hour talking about cloud architectures, Node.js and Rust, and has been a really nice talk. So I want to thank you personally for that. And do you have any plan for the future of your career? I don't know, another book, maybe some open source project. Is there something that you can spoiler to us?
Yeah, that's a good question. By the way, I always find myself in trouble when I try to answer this question because probably I'm not capable of having like a strong vision and being accountable to it. Like for, I don't know, what do you want to do in 5 years? I find myself to be very curious and very driven by whatever is the next shiny thing. I just want to see what's going on. And yeah, maybe I'm going to flip between one thing and another every few months. So yeah, it's tricky. One thing for sure is that I am enjoying this transition between strictly being a software engineer and being more focused also in how things are being shipped and how are they maintained over time and making sure that things are really working, not just on the developer machine, but in production for the users. So probably this is something I'm going to keep investing more. In terms of new books, I don't really have a plan. I haven't started anything. But I'm starting to see some patterns and some stories in terms of this transition that maybe might be worth in the future telling in the form of a book. So again, this is just an idea for now. Maybe it's never going to materialize as a book. Maybe it's just going to be articles in a blog or videos or something else. But I think it's something that could be worth telling as a story. Like, I don't know, how do you ship application to the cloud? What are the different patterns? What could work at different stage of a company, and what could be different needs that could drive an architecture rather than another. Something that I'm enjoying to learn and to see in production. So probably I'm going to invest more time there.
Okay, yeah, that's awesome. So I'll also leave your personal blog link into the description field for the YouTube video for this podcast episode. And I want to thank you again for being my guest for this episode. It has been really, really interesting. And I'm looking forward maybe to have you here again in the future. So thank you again and have a nice rest of the day.
Thank you very, very much for having me. It has been a lot of fun, and I think it's always good to get all these questions because I think I'm going to do a reflection, and that might be useful for me as well. So thanks again for having me.
Thank you. So I hope to see you soon, and goodbye, everybody. See you next episode.
Bye-bye.